Hello and welcome to another LeetCode video. We're going to be continuing on with the JavaScript challenge. And so today we're going to be doing problem number 2636, promise pool. And you're given an array of asynchronous functions and a pool limit. Return an asynchronous function promise pool. It should return a promise that resolves when all input functions resolves. And the pool limit is defined as the maximum number of promises that can be pending at once. And so we would want to try to begin execution of as many functions as possible and continue executing new functions when old promises resolve. So let's actually go through these examples and I'll kind of explain how this works. So in our first example, what are we actually doing? So we have 3 promises and we have n equals 2. So we're going to run the first 2 promises at the same time because we can run as many as we can at the same time. And then we're going to finally resolve the last one. So what's that going to look like? Well, it's actually going to look like this, as you can see. So we're going to run this first one. And we're going to run the second one. The first one is going to resolve after 300 seconds. The second one will resolve after 400 seconds. But as soon as the first one resolves, it's going to trigger the next one. It's going to trigger promise 3 that will resolve after 200 seconds. And so this whole total thing combined is going to be 500 seconds. And then this will be done in 400. And the total time is 500 here. So you could see promise 1 resolves in 300, promise 2 resolves in 400, and the third one resolves in 500 because it has to wait for the first one. Okay, so let's go to the next example. So now we have n equals 5, which means we can run 5 promises at the same time. So now we can run, we only have 3 promises. We can actually run all 3. So one will take 300, one will take 400, and one will take 200. And so they will just run at the same time, and they will take this amount of time to finish, and so everything will be done at 400. So that's pretty straightforward. Now the last one, we have n equals 1, so our promise pool is 1. Now we have one promise that takes 300, so it's going to take 300, it will resolve. Then the next one will run, it will take 400, then it will resolve. Then the next one will take 200. And so the total time the first one will take is 300. The second one has to wait for the first one to finish because we only have one limit pool. So it's going to be 700. And then the last one will have to wait for the first 2 to finish. So that's going to be 900. And so you can see that's what it does. So the return promise resolves at 900. Okay. So how do we do this? Well, you could do a promise chaining or async await, but essentially you need to have some kind of recursive function because if you have some promise and then you have like then you don't really know when to stop, right? You could do like then, like, you know, you basically want a recursive function that as soon as the promise is done, you want to call that recursive function again to check, are there any promises left? And if there are, let's keep executing. And if not, then let's just resolve. So first of all, what we do need to know is we are going to return a promise, right? If we don't use async await. So we need to return a new promise. So that much is clear. Now, here it says actually in the problem that the promises can never reject. So we're just not going to take the reject case. We're just going to say it always resolves. And what are we actually doing here? So we actually need to define a couple things, right? We need to define a couple things. We need a variable to see if we're actually done with the functions. So we'll call that I, where it's going to be like the index in the functions. And then we need another variable to see how many promises we're currently running because we don't want it to be greater than n. And so we can make another variable called in progress. And so that's going to be this. And we're going to use both of these to check if we're done, right? So now we need to make our recursive function that's going to call itself as soon as a promise completes. So we can just say like const recurse. It's going to be a function that takes nothing, right? And what's that function going to do? Well, it's pretty straightforward. First of all, we need a base case. So what's our base case? Our base case is, and you have to be really clear here. So just because you have no more functions to run, there might still be functions executing. And so the base case is actually going to be when we have no more functions to run, aka this I is at the length of the functions, and we can't have anything in progress. So once this I is at the length of the functions, that means we have nothing else to run, and in progress has to be 0. That's going to be our base case. So I equals functions.length, and in progress has to be 0. Both of those have to be true. You have to have nothing running, and you have to have no more functions left to run. And so if that's the case, then we can just resolve this promise that we're doing. So we're going to resolve here. Now what we're actually going to do is what we want to do is we want to make as many promises as possible in this function while we can, right? So we're actually going to have a while loop here. And we're going to say while I is less than functions.length, right? Like while we can make promises. And in progress is less than n, meaning while we can make promises and our in progress array isn't full, then let's just keep making promises, right? So what we're going to do here is we're going to actually, so when we're making a promise, it's going to call a function. So we're going to update in progress because this means we're making a promise. And so we can say, I think we can use const here. Const promise equals, so what do we need to do? We need to actually call the right function at the index we're at. So we can do something like this, where let's say we're at I equals 0. This will call function 0, and then it will increment the I as well. So you could also write, you could write it that way. I think that's like a cleaner way to do it. You could say I++ and then, call the I-1 or whatever. But essentially, you want this to increment before the promise is returned, right? So you can't just say, like, if you did this and then you did this, this promise might be running for a long time is the problem, right? So you don't want to do that. Okay, so you can either increment it beforehand and then say I-1, or you could do it like this. Okay, anyway. So we actually need to call that function, and so we're going to call it like this. And now we need to chain another promise, but instead of chaining another promise, we're actually going to chain this recursive function that's just going to keep making more promises. Because we don't know how many thens we need, right? We're just going to keep recursing as much as we can. As soon as a promise gets out, then we're going to try to do another one. And so we need to do this, promise.then. And then what are we going to do? We're going to make, this takes a function. And so what we're going to do is we're going to say, okay, so when the promise is done, what do we need to do? Well, we need to decrement in progress, right? Because we just finished our function. And as soon as a promise is done, we need to decrement in progress and we need to recurse. And then, so what will essentially happen is, like in this picture, let's say for this first example, what will happen is 300 will run, like this, or promise 1, let's call it, that runs 300, and promise 2 will run at the same time, right? Because in this while loop, we're going to make 2 promises because we can. And then when this promise is done, this will make another promise, and that will be the recursion case. So this will recurse here. And then when this is done, then we're going to have our base case, and we can resolve. So yeah. So we have that, and now we need one more thing, actually. So we actually need to call our recursive function, right? Like we made it, but we never actually called it. And so we're going to call recurse here. And so let's walk through the logic one more time. So we're going to return a promise that's going to resolve at some point. Resolve takes a function. And we're going to let I equals 0, and this is going to be where we are in the functions array. In progress equals 0, because initially there are no promises in progress. And then we're going to make a recursive function that the base case of which is there are no more functions left to be ran and there's nothing in progress, then we can resolve the promise. And while I is less than function's length, and in progress is less than n, let's just keep making more promises. We don't have to wait for them to finish. We have a bunch of room, right? So for this first example, we can make 2 promises. We don't need to wait for one to finish. We're going to make as many as we can, but then once each one of those resolves, then we need to decrement in progress and call this recursive function to make another promise, because that's going to be the cleanest way of doing it, because otherwise how do we know, like what are we going to write? Just like make another promise and then do another in progress. That's gonna, like, imagine if you didn't have a recurse, you'd have to like make another promise here, right? You'd have to make another promise here, and then you'd have to do some increment, and then you'd have to make another promise, and so on, and so that wouldn't make any sense. So the recursion is the easiest way to do this, and let's actually test this out. Okay, so that actually works, and now let's go over the other solution, which is the async await solution. And so essentially the async await solution is going to be pretty similar, but we don't need to actually return a promise because async functions return promises, I believe. Someone can correct me if I'm wrong on that, but I believe that is true. Okay, so we're going to do the same kind of thing where we are going to have this I equals 0, and we are going to write another recursive function, but now it's going to be an async function because we're going to be using await. Anytime you use await in a function, you need to have it be an async function. And so it's going to be an async function, and it's going to be called recurse once again. And so what's the difference here, and what's our base case? So our base case here is actually, we're not going to check for in progress here because we're actually just going to change, we're going to actually have awaits. And so what awaits are going to do is they're going to pause the execution of our context in order to return. And we're going to do one more thing that I'm going to show you that is going to explain why we don't need to check like how many promises are in progress. Okay. So let me show you that in the future. But anyway, our condition here is just going to be this one right here. So if this is the case, then we can just return. We don't need to make a promise here because we have an async function. Okay. And so then, if that's functions, okay. Okay. So now what we actually need to do is we need to await, and we're going to call the function, and it's going to be the same kind of thing, I++. And so what's going to happen here is this will just wait for the function to finish. And once the function is finishing, then it will do more code. Instead of doing the .then, this is essentially the same thing. Await is pretty much do something, and then .then something else. Okay, now we're going to await recurse, and I'll explain what this means. Okay. So the way this is going to work is once a promise finishes, let's just go through our first example again here. Get it maybe a little bit smaller. Okay, so we're going to have promise 1, right? It's going to check, do we have this condition true? And the answer is going to be no. And so we're going to await for promise 1 to actually finish. And then we're going to go to the third promise, right? We're going to go to the third promise and we're going to check, is our I equal to function's length? No, it's not. So we're going to wait for that function to finish. And then when that function's finished, it will call recurse again. And now our I is equal to function's length, so then it will just return here. So that's going to be the flow now. And also, so we're going to make this 1. We're also going to make this 2, and I'll show you later in the code how that's going to happen. And this 2 is going to, you know, there's nothing left here, so this will return as well. And so each one of our functions here that we make has to finish. But let me show you why that is. So what we're actually going to do is we're going to make a promises array here. And we're going to, so in JavaScript, you can do something like this, and I'll explain this in a second. So if you do code like this, essentially what you're saying is, let's make a new array of length n, and fill is like the default element that goes into that array. And then we're actually going to call map on it, and I don't think you can call fill. I think actually maybe you can. Let's test it. I think actually maybe you can call fill on nothing, but I think you can't do this. I think if you do this, it'll get filled to like null or something, so this actually does work. But you can't do this because then your element, you won't have any elements, and so you actually need to have elements to map them. But essentially what we're going to do is we're going to call map recurse. And what's going to happen here is we're going to create an array. So like for this first case, we're going to create an array of length 2. So it'll be length 2, and then we'll have a recurse function. So we'll just call that r and r. And so this will call recurse on element 0, and this will call recurse on element 1 in the functions. And so what map actually does is, for map, you give it a function, and it will take the array that you call map on and give you a new array with every element mapped to this. So it'll call recurse on that element. So essentially what you're doing is it'll call, because the fill is empty, like let's say we just give it an empty string, for example. What this will actually do is it will call recurse on the empty string. And in JavaScript, this actually works because our recurse doesn't take any arguments. So it'll call it on this, but it won't actually use that value. So it'll just do a normal recurse, and then it will fill that in with actually using recurse. So we don't need to say recurse like this because map will actually already call recurse on this string. So essentially, like if you have, like let's say you have 1, maybe that makes it clearer. So if you have 1, essentially what this will do is, if you have an array of 1s, it'll do this, and then it will give you a new array with recurse on 1 and a recurse. It'll call recurse on every single argument or every single like variable in your array. So essentially this will do this, but remember our recurse isn't actually using the 1, so it doesn't really matter. This shouldn't be in brackets. This should be in like this, but yeah. That's what that's going to do. And then what's going to happen is we're going to have this promises array, right? And then what we can actually do is we can call await promise all. And what await promise all does is all of these promises in the array have to finish. Every single one has to finish before this is true. And it will not return until that's the case. And so essentially, let me show you what that's going to look like with our 3 things, right? So we're going to have 3 functions. So let's just call that 1, 2, 3. Then we're going to have an array of recurse and recurse. I'll just simplify that to RR. Okay. And then here's what's going to happen. So we need everything to resolve in this array. So we're going to have this. Now, let's just say this is I for now. So what happens here is the first recurse will be called on function 1. And so we will execute function 1 here. And then we will wait till that's done. And when it's done, it will call recurse again. And remember, every time we call it on a function, we move. So when we call on function 1, this I will move over here. Now, when that happens, this is actually what's really going to happen is, because function 1 has some time to execute, it will actually just start executing. And then it will come over here because we were populating the array right away. And so recurse here will be called on function 2. So this will be called function 1. This will be on function 2. Now we called it, so we move our I over here again. Now our I is over here. Now one of these, I think function 1 finishes first, right? So function 1 finishes after 300 seconds. Then it will call recurse. And then recurse is on function 3 now, so it will do function 3. And while that's doing, I think this takes 500 total, function 2 will finish. It will call recurse. But now that I is actually, now that we call that on function 3, I is actually out of bounds. And so this is done, so this will resolve. So when this resolves, so this will resolve at 400 seconds, but we need the whole thing to resolve, right? Because we called promise all. So while this is still running, we're still not going to resolve. And then this will resolve in 200 more seconds. This is 500 total. And now that these are both resolved, then the promise all will return. But you can't just call promise all on, you can't just make a bunch of promises. You have to make only the right amount of promises that you can fit. And then you essentially chain your promises to like later on functions. So essentially you fill up your array fully as much as you can, and then when every single when any promise finishes, it'll just call the next one in the chain, not the next one chain, but it'll call the next function in the chain. And then as soon as there are no more functions, that promise in the array will resolve, and we need to wait for every single promise in the array to resolve in order to return. Okay, so let's try this code. Let's see if we made some errors. But yes, that's the await version. They're pretty much the same thing, except async await, like I said, await actually means I'm going to wait for this to finish before doing the next code. So this won't return until you do it. And so when, like I said, when you have code down here, you need to structure your code in a way to know that, like, okay, if I have an await here, I need to actually make sure that the code under the await is fine to wait a long time. You need to structure your code in that way. And that's the difference between the .then and this await. Is in a .then, code will still execute. It'll just not do the .then part. Okay, so that's going to be it for this problem, I think. I think I explained quite a bit there, and hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I will see you in the next JavaScript video tomorrow. Thanks for watching.